Hello, everyone, and I'm glad to be here. Today, I'll talk about modern superheroes, reminiscent of our childhood dreams of being Superman or Batman, depends. I'll take the chance and I'll play the role of a modern hero, saving people's lives. For a bit, forget about Andreea. I'm Michelle today, a lead researcher in a life science institute, working on some of the most innovative projects on the industry. Genomic-driven drug discovery uses targeted genome in order to get solutions that are more likely to be successful. Since everyone is talking about AI, that's why we're all here, I took the chance and I thought on how could I actually implement it in our research institute. Maciej, I have a question for you. Is it really safe to give access to that much sensitive data to the machines?
Hello, my name is Maciej Mazur and I'm the lead AI engineer. I will be myself today because I have zero acting skills, so none of that. But basically what we are looking for is security. And obviously any kind of ML system has similar considerations about security as normal like DevSecOps in standard IT, right? It's not non-different than any other project. However, there are also a lot of ML-specific things that will impact the security of the model itself. So we are looking into three main areas whenever we deploy a model. One is the data that it's actually ingesting, both on the training side as also during the inference. There are a lot of adversarial attacks where you can use malformed data sets in order to impact how the model is performing. So any kind of monitoring there is super important. Another one that helps us to detect if there is anything wrong is the explainability part, because whenever the model starts behaving in a way that we don't expect, it might be that there is some anomaly in the data or something like that, or it might be a malicious action. So if you have a proper setup with explainability, you can look into what's happening. And last but not least, obviously, whenever you have any kind of infrastructure, still CV patching, updating it, and making a proper MLOPs pipelines that automate the whole process is super important, like with every other project.
Thank you, Maciej. So far I've learned that it's safe, and actually the right word is secure, to give access and to use highly sensitive data for machine learning projects. And the way to go is with MLOps, which I still shortly define it as DevOps, but for machine learning. And I know you might not agree with me. It's worth mentioning that. But I'll keep challenging you, Maciej, because the truth is that we can think and we should look further. In the healthcare system and the industry, similar to many other industries, such as, for example, public sector, financial institutions, there are plenty of privacy requirements and compliance requirements that we need to keep in mind. And whereas I understand that MLOps does not play a direct role into this space, I do think that it is an enabler for protecting privacy and protecting patients' data in my situation. What are your thoughts about it?
Yeah, so in the project that we are talking about, we are actually, well, not we, the actual scientists, not data scientists, were taking blood samples and doing a lot of research on people's DNA. And it was super important to keep the whole setup secure. So we used a couple of things that enable it to be compliant under the local regulations in Europe. And basically one of them is the data tokenization process, and the second one is strict confinement of Kubernetes clusters. And let me now drill a little bit into the technology behind it. So basically how the data tokenization process looks like, we need the data sets to be useful by data scientists later on. So we cannot just encrypt them, because if we use encryption, then we have a bunch of data that doesn't tell anything, random characters, right, depending on the encryption mechanism that you use. So with the tokenization, we are actually being able to swap the name of the patient to a different name, swap the address to an address in a similar location, so the data is still useful for any researchers into like taking environmental factors in the account and so on. But on the other hand side, this is still protecting the PII, so personally identifiable information. And the strict confinement on the Kubernetes clusters, that was important for us, because if you look at the left-hand side of this picture, this is all the interfaces that a normal K8s cluster has available. But if you use a proper security mechanism like AppArmor profiles and kernel-level security mechanisms, you can actually expose only the bare minimum of capabilities that the Kubernetes should have in order to serve your use case, not everything. So whenever you have quite popular these days, like container sandbox escape attacks, where someone escapes the confinement of the Kubernetes cluster, they still cannot do anything on the operating system hosting other workloads. And that's how we were protecting the genome sampling from the other workloads that were running on the same machine in the hospital.
Looking at life sciences, if there is one thing that is well known, is that we often use public clouds. They help us innovate faster, and they enable big teams to work together. It gives us access to models, to tools in an efficient manner, and we often go with them. However, going back to the very first concern that I had, is it secure this time? I'm not going to use safe. Is it secure this time to actually use public clouds for MLOps and for AI projects with highly sensitive data? At the end of the day, they're public.
Yeah, there are a lot of reservations about that, and obviously whenever we came in and we were asked about how we can extend the capacity of the existing on-prem cluster running the MLOps pipeline into a public cloud, people were looking strangely about putting DNA data into a public cloud during the processing. But what you can do to make it in a really secure and compliant way is use a thing called confidential computing. So basically, whenever you have your own Kubernetes cluster on-prem running any kind of private information, you can use additional worker nodes from the Kubernetes that is running on the public cloud with confidential compute VM. So how it actually looks like is that you open your public cloud console, depending on which public cloud you are on. You choose an image that has a confidential computing built in. There are Ubuntu images available like that. And then whenever you look at your Kubernetes nodes, you have your data center, which is the local node, and some of the processing will be run on the nodes on the public cloud with additional GPUs and capacity that you need for the process. So then you defined taints and tolerations on your Kubernetes cluster, and then some of the workloads can run on-prem, and some of the workloads are running on the public cloud. How this is made secure is with the mechanisms that are built in by hardware creators. So there are things like Intel SGX and AMD Trusted Zones, which basically allow you to set up a thing called Open Enclave, which is a confidential computing environment. And then you have your hardware security module, which is basically a physical key. You can store it in your safe or in the hospital or wherever, and then run the processing on a public cloud in a way that not only data at rest is encrypted, but you also encrypt the RAM memory and encrypt any processing in the CPU.
While I was listening to this, I did realize that actually there are plenty of other use cases in the life sciences industry, such as genome research, cryo-electron microscopy, or biological inside knowledge graphs that could benefit from artificial intelligence. And the applications go far beyond in any other industry, and many of you know them better than I do. At the same time, I do know that open source benefits from a lot of popularity when it comes to the AI space. So I have another question for you, and I don't have many left, but what about open source? Can we actually use it in enterprise-grade environments to run projects like this, especially with highly sensitive data?
Yeah, so that's what we are mainly working on in Canonical, so taking open source products and actually provide proper support for them. So if you take Kubeflow, the most popular MLOps toolchain that is open source, or other tools like that, there are distributions of it, like churned Kubeflow, where you have entire automation, but also all the day one and day two operations, which means that the automation is able to patch a CVE quickly whenever something new arises, not only in the toolchain itself, but also the libraries that are being used in production. So if you look at latest stuff, PyTorch had Shelltorch bug with high CVE score. So that kind of thing will be immediately circumvented by the automation whenever it is detected. And this is all available in the open source space for everyone to use. And we would encourage you to use that in your pipelines, because then you can make it more secure.
As much as I like you talking about technology, I would like to challenge you, because we are building projects like this to help the world benefit from them, to get return on investment. So how can we actually put this work in front of the people? Is there a way that they could really benefit from it, or is just more or less an experimental project?
So we are putting this work in front of people with technology. So basically, whenever we want to run any kind of inference with ML, you obviously don't want the entire set of applications that you get in tools like Kubeflow. So if you deploy Kubeflow now in your data center, you are on the right-hand side of the screen, and on the left-hand side, you have a doctor's office. So whenever you want to train models, you want to do experiments, you need notebooks for your data scientists and so on, you will be running all the 30-something components and open source applications that are part of Kubeflow. But if you want to do just inference, you can use a very minimized set. So in this particular case, the life sciences project that we are talking about, this was hosted on Seldon, and together with basically Seldon, Minio, and Istio, this is like a minimum configuration of projects that you need to deploy. And this is completely enough, and it minimizes the attack surface. So if you see now, there are 4 different components deployed in one setup, and the entire Kubeflow deployed in the other setup. So obviously, when you are doing inference, you can customize and minimize of what is necessary. You can do the same with other tools like Kserve to serve it as function as a service with Knative and all the other applications that you need.
Maciej, does it mean that actually we can run MLOps anywhere?
What do you mean by anywhere?
Can we do it on big clusters, but also maybe on smaller devices, depending on the use case?
Yeah, so basically you can start experimenting even on your own smaller machines, and you can start deploying Jupyter notebooks and things like MLflow, for example, to have your own model registry and then take these models and put them into bigger environments. You can run it on prem environments and also hybrid and multi-cloud scenarios. So all of this is embedded into the automation. So with the single deployment command, you can just choose the target and deploy it on wherever you need, basically.
Thank you. So artificial intelligence empowers modern superheroes to innovate at speed. I'm not Michelle anymore, I'm Andreea. I'm AI product manager at Canonical. I'm done with acting. And together with Maciej, actually, we showed you how you can implement and then scale AI projects that use highly sensitive data. We are here to apply Ubuntu principles to offer secure open source software for MLOps projects. And the truth is that the beauty of open source goes far beyond it. You can contribute to projects and you can make them better every time you bump into something that you don't like. Kubeflow, MicroK, MLflow are just a couple of the projects that come in my mind that could benefit from your help, but they could also be implemented in your organization. Don't shy away from the idea that maybe they don't run on a cloud or they are not secure, but rather try to investigate what are the options that suit the best your use case. And as usual, I say, don't build a project just because you like to talk, but rather because you have a problem to solve. And if you would like to see the full demo of Maciej or other demos from different industries, we are around, usually in orange t-shirts from Ubuntu, and we're happy to get questions. Thank you. I see a question there. I'm not sure if there's.
I'm here representing our company. I'm a risk professional, specifically dealing with compliance. And since I understood your point of view talking about why you can't encrypt the data, you have to tokenize it. But when we start talking about sensitive data and legal requirements, a lot of the regulations actually require encryption of data at rest and in transit. And so I'm wondering how we get in this. I haven't talked to a federal regulator or anything to know if they're considering tokenization and encryption. Obviously, they're two different concepts, but it's still masking the data. It's, you know, and I understand it. So I'm wondering if that's being considered when it comes to the protection of the sensitive data itself.
So it very much depends on the regulatory landscape itself. So this project was done in Switzerland because the company's headquarters was residing there. They had the regulations that allowed that kind of stuff. So obviously, if you are under FedRAMP or HIPAA compliancy or FIPS, like depending on where you are and what is your requirements, you might set up a different architecture. This is not an architecture that will solve every problem. This is a one that was specific for this particular regulatory environment where it worked. But you can use it in a different ways, use other open source projects and other combination with encrypted data, both at rest and in transit. That's also possible. So actually, before changing a company name to a company A in any kind of data set, what I would do, I would add additional columns to the data during feature engineering and extract information if like this company is telecommunication, 10,000 employees, X amount of revenue, and then mask and tokenize the name of the company. Because if you do it beforehand, you are losing tons of information, which makes the whole process useless.
Yeah, that's actually why I dropped it from my use case, because I missed the part where you could, before doing the obfuscation, add more metadata.
Yes, just add additional columns based on, I don't know, any kind of stock information or something about the company, right?
I think we had a question here.
I think you mentioned earlier that part of the tech stack was
Yeah.
which is enabled in Microsoft Azure.
Yes.
To my knowledge, in AWS, it's not available as an what they specifically try.
Yes, that's correct.
So out of curiosity, do you then apply one application formula in Azure and one application formula in AWS?
Yeah, so if we would be deploying it on AWS, it will look differently. That project was happening on Azure because there is a region in Switzerland available for governmental companies to be used and like regulated ones. If we would be doing it on AWS, we would probably integrate with Nitro or apply some other methods. So.
But
Yeah.
I would like to add something here because it ties with both of the questions that there is no such a thing, in my opinion, as an out-of-the-box solution for an AI project that works everywhere. It works in your company, and your company. And that's something that we always keep in mind. How do we adjust it and how do we adapt it depending on the use case, industry regulations, compliance requirements as well. And it's worth keeping it in mind always.
And there might be Ubuntu instances with confidential computing on other clouds coming soon, early next year, but yet to be announced.
Any other question? Not sure? No.
Awesome. Thank you.
Thank you.